Hey folks, welcome to another episode of the Common Lisp Study Group. I'm your host, Ram Vedam with Atlantic Functional Programming. Today we'll be discussing Chapter 19, which talks about the condition system inside Common Lisp. So our agenda is I'm going to first, sort of set the stage for conditions. Primarily talking about how other languages deal with error handling and what sort of approaches are actually used, because over the years originally you would use things like return codes and error codes and stuff, and we'll go through some of the examples of how different languages leverage that, and then I'm going to use that as a basis of talking about the Common Lisp condition system. Peter actually goes through quite a bit of this in there, but there's a couple of things that aren't addressed in there because over time newer languages have sort of come into the stage, and older practices sort of came back into vogue, so to speak. So I'm just going to sort of set the stage for error handling in general, and then talk about the condition system inside Common Lisp, and in particular, hopefully we'll get through this entire chapter and we'll start talking about restarts too as well. To get things started, I thought I would first mention what do we mean by error handling. So often most people say, oh, you got an error. It usually means that there's a bug in the system, but that is not really the case, right? Sometimes it could be things like, say you needed a file, like a log file, and you didn't have access permissions to the file, or the file doesn't exist, or your network connection is unplugged, or some preconditions for your system to actually function, they were violated. So while the system would have worked correctly because these preconditions were met, they're no longer, since it failed, the system won't work as designed. Now, often what you would have to do, and what a lot of people tend to do for systems, they tend to write, things like error codes, tell you what exactly the error is, they will provide you as much information at the time that the operation failed that allow you to address the issue. But, if you didn't handle it, let's say that, you just made things all go hunky-dory, thinking that everything's going to work correctly, you'll never get into an error situation. You might cause a cascade of failures and cause your system to crash. So I like the saying that Peter kind of used, but I'm going to generalize a little bit. Getting an error may not be a bug, but handling an error is most certainly one. Not like, in particular, not handling the particular error that you exposed. So a lot of different programming languages, this sort of area of error handling sort of was researched in a lot of different programming languages over the years. The most common approach, which started, it depends on when you started really writing code. The most common approach really started with writing an error code to standard error if you're using like C, for example. And then you would exit using that exit code. And if someone wanted to go and look into what error it returned, they can go and look at the error code and act accordingly. Error codes were a little bit required you to use some sort of mnemonic to specify, what kind of class of error code you're actually generating, maybe some information inside of a string of some sort, and then it will then return either that error code or in some cases that string. And obviously that's a little bit brittle over time. Certain error codes might mean different things because the system changed and features added new conditions to a particular function, where now the error code that's being returned no longer actually tells you what was actually violated. So what was created, and this was really starting in, with the object-oriented languages, with Smalltalk especially, was the idea of an exception. What you would do is you would throw this exceptional object that sort of encompasses this particular condition of the error that was violated. Like, say you had a file not found error, and you know the path of this file that it wasn't found, you go and return that particular file name to the user, so they would, figure out what to do next, so to speak, whether they can add a new file or whatever. And usually was a two-part division. What that meant was, your exception handling code was sort of in one part of the code base, and your um, code that actually throws a particular exceptions were in another part of the code base. So they really were, sort of a separation of concerns. The interface sort of documented what a particular exception was being thrown, so that you're aware that, okay, there are these exceptional conditions that I need to account for in my code. And usually how you would, catch those exceptions, what types of exceptions are available, those were often at the are implementation dependent based on some API that you would leverage. Or in the case of languages like, say, C++, you could use an exceptional object or a primitive type. So like you would actually throw an integer, saying that, oh, this is invalid, and you could just throw the integer up to some exceptional exception handler above the stack, and it will handle it and do some sort of default policy based on what conditions were violated and how it needs to stabilize a particular system that threw the exception. Now, of course, as you can tell, one of the issues there is and what are the side effects is of using exceptional objects is you are unwinding the stack. So you're almost losing some context in the process of jumping from the exceptional area to the area that's handling your code. And that in and of itself could cause some issues. Like if you lost particular information that you really needed to leverage, but it no longer exists, well, that's a big deal, right? I mean, you can't really tell whether or not, let's say that you forgot to pass in some information about the state of your stack at the time that you threw the exception, and you needed that to perform an operation, say like restarting a network connection, and you don't know the particular issues regarding the network connection, like whether or not the network is down, and you need to notify the user that the network hasn't come back up yet, or do you need to like restart attempting the connection after a certain amount of time? These sorts of things, without the context at the point of the exception being thrown, um, will end up essentially having you to do a lot of heuristics. You'd have to do a lot of trial and error and sort of put in some default policies because you don't have the context at the time that the exception was thrown. So the way Common Lisp addressed this is it sort of dealt with this kind of idea with by creating another level of indirection in its condition system. So you have, same way as with exception handling, you have this idea of throwing a condition. So it will signal a condition in some way. And then you would have some code, and we'll discuss this later, code that would handle the condition. This is handling the condition handler code. And then finally, you have code that I would say sort of acts like the glue. It will create, it will restart the execution after condition has been handled by, calling a particular piece of code, like a function or something, through, and at the time that an exception was thrown in, based on some default policy, you can actually always invoke this restart. So we'll talk about each of these three things in a little bit, but I hope you can see that there is a difference between, how exceptions are essentially kind of, they're kind of throwing away context that you probably actually need to actually make a better decision on how to handle the particular error situation at hand. And we'll see how this is, in fact, quite integral to developing Common Lisp, and specifically the use of restarts, in my opinion, because restarts, I'd never really realized how useful they were until I started writing some dummy like command line programs, and then often I needed to change default values and stuff. So I always ended up using restarts to actually go and take care of that, to allow me to change things while I'm actually developing the code, to make things so I understand the nuances of the code. And when I figure out a particular default value, I would almost always end up using like invoke restart to actually put in a production function call for those exceptional situations. So as I mentioned, conditions are a class of objects. They are essentially subclassed from condition, not standard object. This is actually kind of how object-oriented systems that were built at the time, they sort of followed the same thing. And from what Peter mentions in Practical Common Lisp and what I've read in other sources, this is almost all because of historical consequence, and that is exceptions inside Common Lisp, as well as other languages like C++, who followed sort of like the Simula model. The default superclass almost ended up being always different than the superclass for all classes in the object system. So in this case, for exceptions and conditions and errors, you have condition, which is your top level superclass for all those types of conditions, and for your classes, you have standard object. This, of course, creates certain, peculiarities in how to deal with conditions. One is, as I mentioned here in my notes, is you don't have access to slot value. You have to specify a reader or accessor for any slot that you're providing in the condition. Additionally, you cannot use make instance to create new conditions. You have to use make condition. And because you don't have access to slot values and all that, there's no real way for you to create like a custom constructor for your condition. Instead, you'd have to use the general make condition, and you have to specify your arguments using init args. So an example of this is let's say that you wanted to check for invalid arguments in a function. The book provided something with parsing log files, but I thought this would be simpler for the sake of discussion. The way you would define this condition is you would call define condition, which is just a macro. It does all the subclassing, much like def class does. You specify the condition name. Usually, from what I've seen in production code, and primarily in GitHub repositories and stuff, a lot of folks, when they're defining their own conditions, especially if they are subclass from error, which itself is a subclass of condition, they would almost always provide. They'll almost always augment their particular condition with error, so that when you're reading the code, you know that this is a particular error or not. I don't know if that's just a recommendation or a best practice, but I have seen it in enough code that I will personally recommend that you follow that practice. Otherwise, have a decent enough IDE to go and Splunk your code, and you'll be good to go. But you will make other people have a lot of grief when they're reading your code. Michael Fiano, is this sort of a good best practice that I'm suggesting here? Okay. Excellent. All right. I'm just gonna go with that, and hopefully there are we have other. I mean, I've seen it in enough code that I will say that it's probably a de facto best practice that most people just do by herding the cats. You're at the end of the year, you're blindly following a particular practice without really noticing it. Yeah, but that's a violation of the hyperspec, right? Okay. Right. So it's almost a completely separate hierarchy is what I got when I was going through this, and that's actually a very good point. It's not just to making instances and other machinery related to accessing your object instances and members of it. It could be that depending, and this is dependent upon the common Lisp implementation. But I do encourage you not to sort of in in these kinds of things when it's like separating from error code and object oriented code. I personally try not to stray away from the hyperspec, just so that the code is as portable as it can be, at least at this level, because there's so many other levels where you'll end up making sacrifices to go into the implementation to make your code very efficient. But at least architecturally, you can make it portable enough so that if somebody wanted to go and make it fast on their system, they can do so. Um, so now that we have an error object, how do we go and actually signal this guy? Well, Common Lisp provides something called error. And yes, I know those of you who are probably reading this are like, well, error is also a class that you need to subclass from. Are you saying error is a function? And um, it's it's both in this case. Error is a function and it is an object. Error is what you use to actually go and construct condition in particularly error instances, and you can actually call this guy two ways. One is you can construct a condition object using make condition, and then call error with that, or you can actually uh, call it with the particular argument and pass it in all the init args that you normally do to make condition. So to show both cases, although I was a little concerned about how this would work with scoping, um, I wanted to let us go through this code. This is a little contrived, I will say, but basically it's checking arguments to make sure that for this, at least this add function, if A is an integer, B is not an integer, we'll throw an error saying that they both must be an integer for the operation to hold. I'm being very restricted here. I know it's a contrived example, and this would normally not be the way you'd write this, but I think for discussion, it is straightforward enough to at least for us to discuss this. So as you can see here in this example, we are calling error with the name of the class, well, the name of the condition passed in has the second argument. I mean, the first argument, and all the slot values that we actually specified in this condition here. In this case, we only have something called text. We pass in much like we would normally do with make instance. But how would we use make condition? So one way you could do, if you really wanted to do this, I don't know how often most people would do this. We could also do error make condition type invalid argument error. Pass in your little text. Let's say B must be an error here. And we could then pass in this guy error object datum. Yeah. But I don't know exactly what that would do. So I guess we could just try this out. Let's see. If we do add 1 and 2, obviously this should work. But if we say 2.1, okay. So you could do it this way too. You could create a let form and then create make condition and then pass in the argument, or you could actually do call error directly in this case. But notice here, this is a little bit interesting. You get the full stack trace. All right, you do get the full stack trace anytime you call a particular, and you throw an error, an exception. You get dumped into the debugger. That full blown stack trace is available to you at your leisure. You could go through and step through the code and actually go and understand the arguments that are being passed in. But one thing that I want to at least bring up, at least with respect to slime, and I'll be honest, I didn't know, I was trying to look for this earlier, which is why I was running late. I couldn't figure out where this was. But when I passed in, this argument, the slot value, right? Um, and I don't seem to see it in my actual error message. It says it gives me the object name and it gives me I'm guessing the instance, but I don't see any additional information regarding what was thrown. And that was one thing I wanted to discuss, at least to see if other people who are on the who've seen this type of code, where does this information go, and how can somebody actually look at it? Uh, Michael, do you have any ideas? Okay. It's too bad I don't have Elijah on. All right. Um, so I'm gonna figure this guy out, and hopefully I'll give you guys, some notes on this, and I'll check it in into my the Atlanta FP repository. Which, by the way, I at the end of this I will show you guys where all these Lisp files are actually living, so you guys can play around with them. And do whatever you want to do with them. For some reason, why isn't this? Okay, there we go. Going. All right. So let's talk about condition handlers. Condition handlers are just functions, right? But there is a process that they go through in order for you to properly handle those conditions. Otherwise, you're always going to always land in the debugger. Okay. So, you could think of, coming from like, say, Python or C++ or Java, you could think of, at least this is how I sort of thought about it. You could think of condition handlers and the handler case macro very much like catch. All right. So it's actually, I would actually even go as far as saying it is a try and catch block simultaneously. So you specify what you're trying to express here is the first argument in the handler case, and then for the subsequent forms that are inside this handler case, they can be well, if I find this condition, this is what this is. So you could think of this handler case expression to be equivalent of, you know, try, and then pass in some expressions, and then catch exception E1, catch exception E2, and so forth. Now, one thing I will bring up is you might be thinking now, well, shoot, okay, this is great. I can actually handle these exceptional cases, but what about finally? So, for those of you who aren't, or even, let's say if you're using try with resources in Java, or using in C Sharp, and what have you. Well, those of you coming from those languages, looking at Common Lisp, you might be thinking, well, is there a way of doing this inside a handler case? And actually, what you would want to do is it's inverted. What you would normally do is you would use a with macro. So this guy, if you're doing using, you would use a with macro of whatever you're trying to do. Write the code then with the handler case here, and then you can, as soon as you exit and the form, this with macro will act like your finally. It will close off your resources and do appropriate resource management. I use this pattern. I don't know how other folks do it. There's another case where I would also use handler bind more than handler case, but we haven't touched handler bind yet. So I'm going to take a moment here because I've sort of threw out a bunch of stuff here, and ask, are there questions about this? Because this is some pretty important things. All right. So, assuming that everyone's on the same page here, let's take an example just to to discuss this. All right. So what I did was, going on our adding example, checking arguments and adding stuff. I thought, okay, well, if I wanted just a dummy integer calculator right now, I'd have to constrain how Common Lisp actually does addition, subtraction, and so forth. So I created a dumb, function called check argument that will take in an argument, just check it to see if it's an integer. If it's not an integer, it'll throw up an error saying that an argument is an integer. So the earlier example, and I'm going to show you the earlier example just for so that you can see the difference. This is our original example, and this is what it was changed to. There. No, hold on. Just move this guy to. All right. So in our earlier example, you see we just threw up an error. We're like, okay, we don't know what to do with this guy. How are we going to handle this? Now what we're doing is we're saying, okay, let's check the argument. If we get an invalid argument, we're going to just go ahead and fail out. So the way I handled this is I wrote a let form with failed arguments. Check to see if the first argument is an integer. If it's not, I throw up an error, and then I say, okay, we have a failed precondition, don't do anything. I do the same thing with B, and if we end up getting a failed argument, so that means if failed arguments go from nil to true, this last expression will not be evaluated, which means we won't actually see A plus B. So let's see how this actually works. So obviously, our normal one will work, but let's say that we pass in 2. You can see here that handler case caught the exception that's being thrown by check argument, and it just threw up an error message, and then, just set the failed arguments flag that we then use later on when we're testing to see if we can actually succeed in the operation. And you'll see that this works both ways because of the way the code is written. So if you try doing this here, you'll also see that 1 is passed in, or let me change this to like 3 5 so that you can see that A and B are appropriately being checked, and the exception that's being thrown is actually being appropriately handled. Obviously, this already is looking kind of unwieldy, right? You could see that the way I'm handling this is, I could have created a function here and then just call this guy here. But right now, this needs to be refactored so that you can actually see this. But there's even a better way of doing this, because if you're thinking that, oh, well, handler case already does a lot of catching, but there seems to be a lot of bloat and stuff, then what can we kind of do? Well, that's where restarts come in. What it does is a restart, and I was trying to really figure out the best way to describe this, but you could think of a restart like you are you're separating the error handling probably into a function that you're probably calling, and you're providing a way for the computation to be executed. So what it does is it pauses the computation almost, allows you to change how the stack is actually being manipulated for particular values to make the computation succeed, and you can restart the computation itself. So like in this example here, and this is pretty neat, what I'm doing is I'm checking the first each of the arguments, and if the argument is invalid, I'm asking the user to provide me a valid value, saying that, okay, this is not valid. They can go through and look at the stack trace again, because they're in the debugger. You could actually go look through the stack trace to figure out what would be appropriate, and let's say that you know what the default value should be, or value should be. Um, you can then just go ahead and type it in. And what Common Lisp does is, because this is, running in a REPL, it's just an infinite loop going through waiting for the next thing before it goes and, continues off the computation. It can actually, without unwinding the stack, just change those appropriate arguments and then restart the computation, continue it. So let's see how this works. So I compiled my function. Let's show you that again. If you provide normal values, it will work. But let's say that you do 1.5 and 5. You see now that the debugger pops. We have now our arguments being shown here. You can actually go and step through it, looking at each individual stacks that are available. And let's say that we realize, oh wait, that shouldn't be 1.4, it should be 6. You could then go to this restart case, provide default value, and can you guys see in my Emacs buffer that provide new value for A? That's my prompt that I said, okay, there's a piece of code that I want you to execute for, and let's say that I provide 6 to it. It'll then go ahead and continue the execution. Now, I'm going to say up front, I know if there are sticklers out in the audience that you might be like, well, shoot, you can also technically provide an invalid value and your code will still run as if it succeeded, And I know that it's not a robust example. I'm just illustrating here, what you can do, Oh, actually, I can't because I'm using parse integer, right? Oh yeah. If I change this guy to something else, like if I didn't do parse integer, I just did readline here, things would be different. That's why, folks, you need to use what's built in there. So I actually wrote it correctly earlier. Let's see if this works. Nope, not a type number. I have to try something here. Not a type number. Oh, interesting. Okay, good. Yeah, it does work the way I expect it to. Okay. So let's say though that we're at this point where we're restarting. We have provided different restarts, and now we're like we know what our restart should be. Okay, let's say that we want in this add example, if you provide an invalid value, you want to default it to be -1. All right. Obviously, this would be kind of dumb, just because you're adding -1 always to whatever computation you're doing here. But just for argument's sake, let's say that we are going to provide -1. So now you would want to use handler bind, and I have to go and remember how handler bind actually works, because I've forgotten right now. Okay, but for this, I'm going to just say how would I do this? I'm forgetting now. I'm gonna go check something here, guys. Sorry about this, because I'm forgetting the syntax. Right. So the difference between so we were talking about restart case and stuff, but the difference between handler bind and handler case is something to be noted for, as you were probably noticing in my code there. So let's do this. We can actually do invalid oops, sorry. So if you know, our handler bind takes in two arguments. Let's look at the signature first. You have your bindings and you have your forms. So in your bindings, you are checking to see invalid argument error. And what you specify there is for that specific error that you're looking for, you are going to go in and return 0. All right. So we're not actually calling a particular function here. We're just returning 0 for. Actually, no. We need to do something here. Let's just go do this. Invoke, restart. And we'll specify evaluate to 0. Okay. So in here, now, if I'm recalling, you are, if you do, what is it? It's going to be, if check argument A, check argument B, then A plus B. Okay, this should be correct. And I have an error. What was that error? Did I mess something up? It's never used. Still have a warning. Oh right. I need to go and do this. Yeah, this is one of the problems of live coding, folks. I apologize for that. That's correct. So this should work. Let's see here. Did I mess something up here? I think I did. There's something I'm missing in my code. This guy? Yeah, that's it. That has to be it. Okay, that's it. One style warning. Let's see here. Add 1, 2. Okay. 1, 1, 2. What does it say? No restart is active. Of course it's not active. Hold on. I wrote my error wrong. This guy needs to be. Do this. Hold on. I'm going to change it the way I normally see it. Let's see. Invoke restart. Evaluate to 0. And. Right. I remember now. Because of the way I wrote this, that this is not working. Efun perform add restart case. Let me do this. So if we just simply call this and just do so what I'm adding to our add function earlier is a new restart that'll just simply set A and 0 B to 0. Well, set A to 0 and B to 0 depending upon whether or not their arguments is invalid or not. So here, oops, evaluate to 0, set FB 0. Okay, so now instead of me doing this, not this, sorry. Okay. So now if I do add 1, 2. Okay, good. So what I did here is, let's go through this code a little bit. So to use handler bind expects sort of one or more restarts to be inside one of the functions that you were doing. And earlier, my mistake was, and this is why it was taking me a little bit of time to actually correct this, with handler bind, it's looking internally into each of your functions, and only if one of those functions sort of like pops out and asks it to handle this particular error does handler bind actually call this anonymous function that we defined here. So in this example, this new add that I wrote, it basically, when it gets an invalid argument error, it actually goes into the function and say, okay, function, invoke this particular restart that should be available in your list of available restarts. Obviously, this sort of implies that each function will have sort of a list of set of restarts that should be available to the user when they go and implement this. And in production code, this is actually, I think, the right way of doing this, which is, you write a different set of restarts for development as you're going through. And then when you decide, okay, in production, what I want is in this particular exceptional situation, I want you to always do this. This way, you never actually pop into debugger. Instead, it will just resume execution. And often, one thing that you can do is leverage, writing to a log file as being part of a restart. So you could say report error, and then internally we'll take the stack trace, write it to a log file, or even send off an email to somebody. But continue resuming execution so that the system will never actually die or stay in some sort of unstable state. It will actually reset itself. Now, this, as you can see here, is probably kind of ugly for folks. I mean, for now it's simple enough that it's pretty easy, but it could be multiple lines, this anonymous function. So another way of actually going in and invoking this guy is doing the following. And I apologize for the quick indentation mishap there. But you can actually, create a new function, and then which takes in an argument. That argument is the condition object that's actually being passed into it with all the information inside the actual condition. And we can actually go and look at that if you really wanted to. I'll play around with that a little later after I demo this to you guys. But once you define this function here, what you could do is then just say mal for handler bind, what error, what function to call, and it'll go and behind the scenes call the appropriate restart. So this essentially does the same thing that we did earlier, which is it will go ahead and call the appropriate restart, which in this case is 2. Let's say that we wanted it to call what I had, which is provide default value instead. Actually, I'm going to make this into a new function instead. Let's say provide value C, invoke restart, provide default value. Okay, now say provide so you can see now when we change the handler bind, it automatically says, okay, provide new value for re. You can actually say more meaningful error messages, but right now I have my default value there. Obviously, we haven't even kind of like scratched what you can actually do. Like you can actually provide multiple restarts, which I given you an example of this here. So if you call this function perform add directly, you'll see in your debugger multiple restarts. You can actually evaluate to 0. You can actually provide the new value. This, for those of you who are watching, will become an apparent thing for you, which is every restart that you write, every handle that you show up will become an option inside your debugger. And it gives you the ability to actually call that function directly. You don't have to like provide any additional value. Your Lisp actually goes through your restarts for a particular function evaluation and looks it up and provides you to you as options inside your IDE, which I think is pretty cool because it gives you the ability to at the same time implement multiple different strategies and try them out based on different types of permutations. And I think that's pretty cool. There are other cases where it becomes even more useful, but I think from an interactive development standpoint, this is a key feature that I think is lost when you start dealing with other languages. It's I actually am very fond of this particular feature in Common Lisp. I won't lie. Are there questions? I hope this isn't confusing those of you that are on. Judd, you seem to be a little silent there. Yeah, looks like. All right, cool. So there's a lot of other errors that we could go through certainly. I think one thing that the book mentions that I'm just bringing it up just to make sure I know this, is the concept of the debugger hook, which is something that has been so the debugger hook basically is so everything inside Common Lisp in terms of actually dealing with conditions is calling a very low-level function called signal. All right, this is a mechanism that it triggers the signaling machinery, the conditioning machinery, to go look into the function, look into the handler function, see what handlers are available, populate what needs to be thrown into the debugger, create the debugging context, and then throw it to you. So it's actually a little bit of a process to actually do all this. The function that we've been calling error calls this function internally, and the other functions does too. Now, if signal actually returns, what error does at the very least is it calls a particular function that's stored in a global variable called Debugger Hook. So if you want to look at this, you can actually go and look at Debugger Hook, and you'll see that in our case, the Debugger Hook in my REPL is actually essentially calling Swank, which will populate its data structures and give a meaningful error message to folks, and provide the restarts there too as well. There are other types of signaling functions instead of error. So you have things like warn. So let's say that instead of error we use warn in our check argument function here. Um, and let's call perform add again with that thing. You will notice that I can't just simply change the function called, because warn is a different type of class than error is. But what it does basically that I want to show you is it does actually spit the condition out to the stream error output, much like what you would think with standard error. There are some other functions that I've never honestly used. I don't. I've seen other people use it, but I will, because I'm still kind of like uncomfortable with them, that I can't really I mean, I'll bring them up so that you guys are aware of. But I've never seen them like control error, signaling a control error, or using C error instead of error. There are these other error functions that you may stumble upon as you go through it. Additionally, there's also a restart function already available called muffle warning, that you can put around a particular and you can actually call it like warn does, which will actually muffle the actual error that's being thrown, and then just allows the execution to continue. But I've never used it again, so I don't want to I don't have a good example to actually really illustrate that outside what the book would have provided. But that's I think in general, we've covered a good intro and a lot of material in this particular fire hose of a discussion. I will say that of all the features, conditions are often overlooked. Most people, at least from code that I've seen, often use handler case versus handler bind, and don't provide enough restarts for me to like really play around with their code bases to see where one particular thing would be better than another one. That's probably because they're shooting for production quality Lisp codes. But I will say that if you are developing, restarts are your friend. They are not something that you should just say, okay, there's this nice little feature that we could just do, but as long as I write handler cases correctly, I'm okay with ignoring this restart function. This is actually really important because it gives you a level of indirection that you're losing by using handler case alone. By using restart case, providing restarts, and then using handler bind, you are actually making your code more robust than using handler case alone. But this is my opinion. I don't know what other people opinions are on that. I've seen folks, just only use handler case, much like they would do exception handling in other languages. I've seen some people using restart case only, and not, and then, which is more like a debugging tool, and then say the caller is responsible for creating their own handler binds and figuring out what they need to do. How you design your API, how you design your Lisp library, it's all up to you, but when you're developing it, this actually is kind of useful. Are there questions? Discussion? Yeah, sure. Restart bind. That is a good question. I've seen this once. I've never actually tried it, but that's let's play around with it. Let's see what we can come up with. You know, that's I have to go and remind myself how restart bind looks like. It's much like handler bind earlier today. This is restart bind. Give me the hyperspec. Come on. Do. Okay. Give me a minute. Hold on. That's okay. So internally, restart case calls restart bind. So, but let's see what we can do here. We can call restart bind directly, but it's lower level. The suggestions that I've seen, this is from Common Lisp to Language, actually, the second edition. I will send this to you guys so you guys can take a look at this. Let me share my screen for folks. But I'll actually post this inside so that people who are watching this example of so sample reference from here. If you go to this, you will see that restart case is, where is it? Here we go. Code referenced from. So if you go to the CMU channel, you would end up seeing this this piece of code, which is basically showing you what the equivalent is. If you write multiple things in a restart case like what I did earlier, what it does internally is it'll macro expand this guy into a restart bind. So let's see if I could do a Control C, Meta M, and close this guy off. Close this guy off. So that def add ended up creating a restart bind. Oh, it doesn't actually use restart bind here even. That's interesting. So on SBCL at least, it doesn't actually follow restart bind, but others might actually do this, something different. Interesting. Of course, there's also something else that I haven't shown you, primarily because against the book, the book gave a nice overview of everything, but I didn't really, sit down and actually look at some additional things here. But there's a nice little thing called with simple restart. Like if you wanted to do like something like this, if you're creating a REPL, let's go back to my. Okay, so let's say that you want to do something like this. This is from the hyperspec actually on with simple restart. Okay. So here we're creating a simple read val print loop, and you can see that if we execute this guy and try to run it, say And you will see that it will eval everything, but you can also actually abort the level that you're in. So like you see here in our restarts, it says, okay, return to command level 1. You could see that, oh, okay, we can actually go and jump in and stop the read. But what you'd want to do is probably exit, and it'll go ahead and exit out of the function automatically. This is kind of useful if you want to have an abort function in case that you are, um, doing some sort of resource management, and you hit like a particular race condition. I'd use this just so that you can exit out and abort the actual thread from actually doing anything dumb. But there are better approaches than that if you're going to do that in concurrency, which we'll discuss when we start talking about threads and stuff like that inside Common Lisp and concurrency in Common Lisp in general. So yeah, so I don't know about restart bind, Michael, but with simple restarts, a good close thing that I would also encourage you to look at. Right. So reading the Common Lisp hyperspec here, it would seem that the function, interactive function, and report function passed into a given restart bind would actually they'll be evaluated unconditionally in the current okay, right. So without you're absolutely right. Without actually unwinding the stack, if you pass in all three functions, which by the way we only touched one really, which is the default interactive function form, but you can actually pass in multiple functions to restart case itself. And again, this is actually because it calls restart bind, it automatically goes thrown into restart bind. You could, simply in our restart case example here, which I provided multiple restarts here, I could provide also a test function too as well. If I recall, hold on, let me just make sure I get the code correctly. Test function. Because I very rare I tried this once when I read the hyperspec a long time ago, so I apologize if I'm messing up the code a little bit, but there is a way of doing this. Here we go. Let's do report instead. So you could do report here, and you could pass in a lambda that takes in a stream and say format stream a was not an integer, and then it will continue on going on your forms. And then this guy is going to be our interactive lambda stream. You could just pass in the stream here. Okay. Oops, I messed up one thing. All right. So if I did all this correctly, you can go ahead and return this, and let's see what happens when I do 2 invalid number of arguments. Provide a was not an integer. This guy. Oops. Port. Okay, Michael, for you, I'll write this example and I'm going to show this to you. I'll check it in and I'll send you an email from it. All right. Right now, I can't seem to figure out why this is not working. I have to go and do some digging about it. Any other questions? Judd, Mr. Gargano? No problem. All right. So, until next time, uh, we will we'll be discussing obviously the next chapter, which is on the special operators that are in Common Lisp. We touched based on a couple of these, in previous lectures, but we'll be going through it in much more detail. Although they say there are about 25 special operators in the book, I've noticed that there are a couple of more than that, I think, and it, it you'll keep on finding them over the leaves. The ones that are mentioned in the book are probably the ones you'll encounter most of the time, and but knowing that there are other ones too as well might do you some good too. And I does it now? I think SBCL. I thought I saw a couple of them. Those might be specific to SBCL though. I might be thinking that uh, SBCL specifically, and I do apologize for that if that's the case. But um, there are some nice ones that we'll be going through them. We'll go through them, next time because there's a lot of them, and a couple of them, a couple of the operators, just to give you a taste, come from existing languages. Their syntax are available in existing languages, but the syntax is different from the semantics. All right, so one example, just to give you an example, is go to, or even throw and catch, for since we're talking about conditions. Um, Throw and catch are definitely different than try catch and try accepts constructs, um, because uh, they're not the same thing, and it requires me to go through and talk to you about some other special operators in order for me to actually um, show you why they're not the same thing. It goes back to how Lisp has grown literally over the years, and it took on and stood on the shoulder of giants, and it kept grabbing more and more stuff from other Lisp dialects as it started getting standardized. But that's for discussion for another day. Um, if there isn't anything else, I'm gonna end it today. Thank you so much for listening, and entertaining me, for giving you this nice discussion on conditions and restarts. Thanks again to Michael Fiano for providing some insights and always giving me new information all the time. Uh, and I hope to see you guys next time. I hope to see you guys, if time permitting, in the game jam that's coming up in a couple of weeks. But in 10 days, exactly. Right, that's right. We're already at the 10-day mark. It's exactly 10 days, April 20th to April 30th. Join us in game dev on Discord, or on Lisp games in Freenode. And until then, this is Ram Vedam signing off. Thank you.